be traveling. We're going to record this too, just so that we have it for later use. But as we get going, I did ask Murad to kind of share his experiences of what he had in his previous employments with Nashville and Tennessee with drone use and traffic and signal operations. So as we go through this, this is not, a formal presentation. Please speak up, ask questions, provide insight, whatever it is. We want this to be a very, informal type of discussion on possible uses for drones for signal operations.
All right, so my master's research was drone and AI. I use a DJI Phantom 4 drone, and it is a 25-minute flight time. And then at TDOT, I use a DJI Inspire 2. It has a 30-minute flight time, and you see that the camera is very high resolution. It is mainly DSLR camera, and we can attach tether with that drone, and it can stay on the air 2 days, 3 days. It doesn't matter if you have power on there. And then for Android, I use Skydio 10X. So the good thing is that this drone has a thermal camera and visual camera, and flight time is 42 minutes. Again, it has also zoom capability. We don't necessarily to fly the drone over the traffic or crowd. We can fly the drone near to that, and we can make the zoom on there. So the other drone, this drone, it doesn't require any pilot. So it has a tether capability, also thermal, and it has 150 feet tether cable. So in your district, if you do not have any drone pilot, you can use that. Okay. So mainly in the video, you can see that you can see put the drone in here, and there's a cable. The drone can stay on the air as long as it can power. So you can take the power from the car, from the nearby power supply. And the good thing is that drone is lightweight, so it doesn't require any pilot, and it has automatic flight and height. Yeah. So for district office, if you don't have a drone pilot, we can use that one. The next one is that this is a ramp service interchange queue length monitoring and advanced detector placement. So this is a I-24 interstate. The traffic points they come, there is an intersection in here. So during peak hours, traffic, it blocks very long queue overspill. So we fly drone, check how long the queue is, and then based on that, we put the advanced detector so that it can call with the controller and clear the traffic.
At what height was you in
that? For the drone?
Yeah,
Yeah, so the maximum height we can go 400 feet. So I was flying in here, and you said that there's a long queue. They are waiting for it, and during peak hours, always there is a queue still. And so then we decided to place the advanced detector somewhere in here near the queue.
That'd be good for IMCs.
And then next one is the traffic progression analysis along a corridor. So we retimed. Okay. So we retimed a corridor, knowledge build bike. So after the retiming, I fly the drone and try to see how the traffic is progressing. Is there any blocking issue? Like this is another signal, and there is another signal, there is another signal. And you can see there is some blocking in here. So we talk with our consultant and give them the video footage. So the interesting thing is that this is a major intersection. Major means this is a major arterial, this is another major arterial. So it is hard to coordinate this one. So our consultant, they came up with signal cycle length increment every third cycle, like 50% time in increment. For example, if we take 50 seconds for the first cycle, it will be next time it will be 100 seconds, and next time 150. It will go on then. So it will give the adjustment on both corridor, and from there you can also see we can use the drone for queue length assessment.
Hey, Murad, I think Keith's got his hand raised. I'm not sure if you can see it since you've got the presentation up.
Go ahead, Keith.
No, that's okay. Keep going. I'll wait to the end. So I didn't want to. I don't want to interject in the flow. So I'm sorry. Yep.
So so I'm mainly observing how our signal rate timing and in any of the split adjustment required. So this is another corridor in here. So you can see from here, trying to observing the traffic flow, and there is an queue in here. So we talk with our consultant to check that queue because the minor approach is very minor traffic in there.
Now, is this drone here tethered or is it
It's not tethered.
not tethered? Okay. Keith, are you familiar? We did a drone. There was an experiment or something done several years back. It would have been prior to COVID. I remember going to see it. It was in Salem.
Yeah, I'm very familiar with that whole thing and how it played out and all the little nuances of what worked and didn't work.
Okay.
And then I've got this kind of lines up great because I'm on my way to Massachusetts today to talk about this type of drones, but then drones in general with Massachusetts DOT. So when I come back from them, they've done 5 or 6 direct traffic operations studies that kind of continued what we did earlier. Kind of either added on or branched off from for drones and traffic ops. So again, I've seen that 2019. I think it got published in 2019.
Okay, that sounds about right.
For that report,
I just remember
it's sitting on my desk.
It was tethered.
Yeah, so
the one I saw was tethered. So yeah, at least the one in Salem, the way they did it, and I was actually impressed with it, but I don't remember the final study. I probably read it, but don't remember what their conclusions and stuff were.
Well, the big problem with that one is that, and we still have that requirement, you can't just leave a tethered drone by itself. Right. And depending on the authority that you're operating, you're still required to have a pilot. So just because you buy a tethered drone doesn't mean the requirement to have a pilot goes away. And that's kind of a big misnomer. Not having a pilot only applies to police and fire. It doesn't apply to us. Okay. Right. So we'd still have to have a 107 qualified operator, probably 2. And we'd have to sit there and man it the whole time. So you can't, unlike what California was able to do with some of their permissions, they're able to set it up and walk away, but they're not using it for traffic operations, right? So their tethered operation is in very rural, remote areas. So they can set up they're really limited too. They can only go up to like 45 feet or 25 or 40 feet. And then they can walk away from their tethered drone operations. We go a lot higher than that. The good news is well, again, if I'm leaning on our attorney with the support from the chief deputy. to get authorization from the FAA to operate our drones as public aircraft, which will give us the authority to go up to 700 feet, tethered or not. But again, this stuff takes time, right? I've been trying to get that approval for a year,
Yeah.
and we just sent the letter off to the state attorney's office like 3 months ago, asking
Okay.
for this. So these kinds of things are coming. You know, the developments are coming. The big question is how do we get the data from the system back to, you know, traffic operations, whether it's an operations center or the engineers who are going to need it in a timely fashion, that doesn't require thumb drives.
Right.
I have some slide. I will talk about that.
Okay.
Yeah.
Great.
Okay.
That's a good question.
Well, thanks. I'm just glad you're aware of that stuff that was done in 2019. I wasn't sure who all was involved with that. I just remember
yeah.
going to the site and watching it.
Yeah, I caught the back end. I like the report of that. So
Okay.
We don't
good.
always need a real-time streaming video back. And I guess one solution I'll offer to that is, you know, assuming you had a remote pilot in command on scene, flying the drone, you could take a screenshot of a point of interest and send it to the local TOC, and that would be distributed through normal channels that we do every day. Like when we have, you know, a tractor trailer overturned and we transmit a picture like that. So the streaming video, I agree, would be a challenge, but I think you could take individual screenshots and use the normal channels. But just one piece to the puzzle.
oh right,
So,
yeah, definitely one of the path of least resistance, right? So if we already have a mechanism
Yeah.
that works, that's what we're going to pursue, right? So
Yeah.
and again,
The incident management coordinators on scene, they'll take a picture of something and then send it to the TOC. That's routine.
yeah.
Okay.
Well, again, so at the end of the day, you're the client, right? So we'll figure out where you want it, and that's what we're going to do. So,
So we did that at Nashville. The Skydio has their cloud storage, and they have a account on there. And using that, they generate a barcode. So you can share the barcode anyone, including TNC, police, fire department. They just scan the barcode and they can have the feed. So to get the stable feed, we bought a separate COM. It's called a separate thing. So the device, it takes 5 types of carrier, AT&T, Verizon, multiple types. So if one COM drops, other COMs, they support to streaming it. So you can have the real-time data, and it doesn't matter who are you sharing with that. You just need online an account, schedule account. That's all.
Mike, we could put this on the hour app. Incident response app
Maybe.
as a feed.
Maybe. Yeah.
So here's what I would suggest for this. So one way we could distribute the video is using our Skyline contract. So what we do, like, let's say, I'll give you an example. So Hampton Roads, a city, has cameras in their jurisdiction, and Skyline sets up a VPN tunnel to those cameras, firewalls, all the necessary cybersecurity stuff, and it gets piped into 511 or Claris. So you could theoretically, if you could get the components to work together, take the video stream from the drone and bring it into secure Claris, where only VDOT and VSP and maybe a few other trusted partners have access to it. It doesn't go to 511 or anything, but that's another avenue where you could bring that video feed into the TOC or in your pocket somehow to access it on your phone. So just another solution.
Nathan, I can give you two options in here. One option is through the Skyline. Another option is through the web, the Skydio Cloud web client. So the web client users need an account, but for the Skyline, you need to have some firewall set up and other things set up to share the video. But there is a way.
yeah, I'm
All right.
aware of two other studies going on in Hampton Roads, not with us. We were invited early, and I'm kind of like a tag along, if you will, on this. But I know that the police and fire down in Hampton Roads are working on getting their video feeds into the Claris system. I'll reach back out to them and see what their success rate is, and so we're not duplicating effort. We might be able to fall into something that they've already done. Anyway, I'll follow up with that when I get back in town.
All right, thank you. Sorry, I have a 80 slide, and I think I need more additional time. Okay, so after the corridor run, then I checked our Centrex time-space diagram, and we adjust different offset where we find the blockage. And after that, I use the RITIS for additional data analysis. As you can see, in May 2, the speed was 10 something. In May 3, the speed gets increased 16. So it's a huge increase in there. In northbound, again southbound. So although the corridor was retimed, but on that major intersection, it was a very hurdle for us to get. And it's improved from there. And then also we did indecision or dilemma zone study and advanced detector placement. So the general practice is that the driver usually show indecision or confusion when the yellow light change is 2.5 to 5 seconds. So we study the corridor and we put the advanced detector in a video analysis tools, and we simulate different features on there. And then this is the access management and turn restriction study. So in here, there is a signal in here, there is signal other in here, there is a facility that generates a lot of traffic. So when people take left turn in there, there are some crash history. So what we did, we fly the drone, we see the traffic pattern, and after that we implemented the medians in here so that the people cannot turn left turn in there. They have to by forcefully go there and then take the other routes. So that's another thing. And then this is the special event management. So Nashville, we have a Music City, and it's we have a corridor. It's called Broadway, and it is messed up when there is a like Taylor Swift come, and whole city was shut down at the time. So what I did. So I fly the drone on there, and mainly I observe the corridor and the pedestrian, how they are crossing the intersection. And also you see that there is a entertainment vehicle. So the corridor is mixed with different modes of, and so I mainly fly the drone to study what's the pedestrian gap size we need because the special event, pedestrian can come thousands or sometimes more than that. How can we accommodate our pedestrian signal on that time? And as you can see, people sometimes they block the intersection. And then the other one is that after we capture the special event, I use a Skydio drone, and they also have thermal video feature. So with the thermal video feature, I can also measure the pavement temperature in here. And I talk with Richmond District Materials Division, and they are very interested on that. So how can you fly the drone and find the real-time pavement temperature for the materials and testing? And then, so using that, you can also see that the left turn, it already overspilled. And how can you adjust your signal timing to clear that? I have the video. So the good thing is that using the thermal video, if you use different analytics tool, they can capture this pedestrian, they can count it more precisely than visual one, because the thermal, it avoids the shadow, and it can detect pedestrian object clearly than the other things. Yeah, and also the privacy for the individual person, it also not disclosed, so we can use thermal if there are any concern or private issues. Like there are some council members in here, so they do not try to say that I'm drinking on there, having some fun.
Yeah.
We can use that thermal video. Yeah. And then, so we use a tools, it's called data from sky. So this data from sky, it gives us the, data from sky. So using that, they gives the pedestrian flow, like using the thermal camera, it gives us a different pedestrian flow, how they're crossing it, number of pedestrian. They have nice tools they give in the setup. And then this is, so again, I use the drone for our special event coordination with police department. Yeah, so you can see the police in here. So we share the feed. I share the feed with the police department, our TMC, our higher leadership, also mayor office. Mayor office also observed that. They try to understand how many people they come, and they try to adopt different things on there. So police come in here, and they saw that this intersection is affected because we have one zone nearby with that intersection.
I don't know if anybody else has seen this policy, but what came out of 2019 with our policy to support Virginia State Police, we're extremely limited about what we can and can't share coming from a drone with VSP. We're supporting VSP. But again, I know that other DOTs have different operating authorities, but the Attorney General's office kind of put the brakes on what they proposed in 2019 with VDOT and VSP operate what I'd call interagency support. So we could probably do this for traffic studies, but as far as sharing that data, that's going to be a harder little harder coordination effort with through the commissioner's office, just for FYI.
Yeah, so for same things happen for our city. So we make an exceptional if the drone is used for the traffic study and for a special event management, then there is some exceptional. Otherwise, you cannot share the video with that. And there is an work zone here mainly. So I also use the drone. How can people be touring in here? And there are traffics in there, so it helps us to manage the work zone as well. Then next one is the pedestrian level of service, and then pedestrian control delay, and then pedestrian gap study for signal retiming. And in the video, you will see there are signals in here, and we have a right turn, no red on right turn restrictions. So although there pedestrian is still crossing, so after that we what we did, we analyzed that if there are any larger group of pedestrians and in the pedestrian there are probably younger or elder or disabled pedestrian, they might need more time. Then we analyze the gap study using that formula. And then we implemented extended pedestrian sign installation on that corridor and create a special event pedestrian signal timing pattern for different time of the day. And it also increased the clearance time, right? Radial green for the pedestrian safety.
Assuming you ran exclusive pads there, right?
Yeah, exclusive bed.
Yeah, the X.
So again, as you can see in here, this is red right now. And when the pedestrian cross, there will be no right turn on red. So the issue is that we set up a special pattern for the pedestrian, but when there are lots of pedestrian or they purchase more tickets, then those are not covered. So using the drone, we try to count pedestrian and how much signal timing or pedestrian timing we need to implement. You can see in here. And they just cross in different ways.
You're blocking the chat.
That looks like New York.
How many pedestrians an hour were you guys calculating through these?
Yeah, I'm counting on that next slide. Yeah, so the next one is the pedestrian count using the data from Sky. So when you put the video in there, data from Sky, it can count, and it also gives the pedestrian flow rate. That means per hour, how many pedestrian is going, or every 15 minutes, what is the pedestrian peak flow, so that you can count different pedestrian timing. And again, we also have it's called pedestrian bridge. And it's near to the Nissan Stadium. When there is special event happen, it's like a zombie. They are coming from different directions. You can see from there. The stadium is on that direction. So we have mid-block crossings in here, and pedestrian they are crossing there, and this is the traffic. So we use the drone to count how many pedestrian they are using, and in that way we know how many people they attended on there. So we just try to monitor different access point of that special event. And this is the minor approach control delay study. Again, mainly we give the time to the major approach, but for the minor approach vehicle, they have to wait for a long time. So we again study for how long they are waiting for at the green time. So you can see the rate in here. So we are trying to calculate the control delay for minor approach. And the other one is that control delay and traffic movement count, TMC count in there. And you can see that there is a rail track in there. So this is the major corridor in here, and how railroad preemptions timing we need, and if the railing going this way, how the traffic are overspilled from other intersection or upstream and downstream, how the queue length is affecting our signal operations. And you can see that the queue length and the traffic in there. And I'm in here. So yeah, people are taking left turn, and we are using video analysis to count all the turning movements in here. Also, we see that the rail track unfortunately, I'm not seeing here, but using that, we can also see that railroad preemptions, when the rail pass, how it is impacting other intersections, what is the queue length, and in that way, you can know which phase after the rail pass, which phase should be released to minimize the queue. And then same this one, and then also during NPI implementation, we also implement LPI, leading pedestrian interval. So after implementation, I apply the drone, try to capture how we implement in a good way or bad way. So I found that when people, this right turn, you see that this is right turner, they, although if it is red, they feel that they can move in there. So this pedestrian is waiting to cross. When he start waiting, you will see that this car, he almost like thought that he can cross. So he have a heartbreak in there. So if it is in during nighttime and low visibility, especially if you have rain, LPI sometimes it could be dangerous. So what we post in here that no red turn on right. So no right turn on red sign. So that's a good indication. And then again, queue length management assessment. We study different overspill queue length on the corridor. Similarly for this one, and we also know how many vehicles are there. And then for the so also we did a in the LiDAR, we installed LiDAR, 12 LiDAR. So there was a fatal crash in that location during midnight. So the drunk people, they are crossing. There is a store in here. So they cross and they got hit and they were killed. And I use drone to fly all the corridor and try to capture different condition diagram for crash assessment. Condition diagram is what are the traffic signs, what are the infrastructure are there, and it helps to identify the crash reason. And then after that, we use the Blue City. It's the LiDAR software. The Blue City, we analyze the data on that location, and here is the location. And then using the Blue City, we count how many traffics are there and what are the outside of crosswalk event happen. That means the pedestrian, number of pedestrians that are not using the crosswalk, they are using mid-block. And for 1 month of data, we found out that most of the pedestrians, they are crossing this way because there is the facility in here and this way. So later, I was the project manager. We installed the mid-block in here with right appropriate sign and rapid flashing beacon. So when LiDAR detect pedestrian, it gives the flashing so the driver can aware of that. So that's another way we can use the drone for condition assessment. Also, we use a drone for LiDAR data accuracy validation. So here is I'm flying the drone here. So the LiDAR is in here. So the pedestrian is crossing in here, and the LiDAR, it is in here and here, and you can see that there is a flasher. Start flashing there. So when the pedestrian touch the crosswalk, LiDAR detect the pedestrian and it start giving the flasher in here. So you see that the flasher will turn on and it will start flashing in both sides. Also, we use that video and then we match the timestamp and LiDAR output and drone output, and we validate what's the data accuracy for that.
The signal was green during that time.
When pedestrian cross, the signal was green. This only the flash star is going on.
Need to check on that. Okay, so the other one is the school zone queue assessment and school zone signal timing pattern development. You can see that it is a very long queue in here, so it overexplained there. So we develop a special pattern on that signals for the school zone on the time, so that people can go there. And then this one is the construction project update. I use the drone for TDOT public department. And mainly the commissioner wants to have an update on the bridge construction, what is happening on there. I fly the drone and give a nice footage, and they know what is the construction for the update. So it can be done like every week. I can take a flight for a week and then next week or monthly, so they can get the updated how long the bridge is. And also this one is interesting. So we use the drone for I-24 camera installation. So you'll see me in here. What we did when we put the train in here, we close the 2 lane, and when we start putting this camera pull in here, we start the whole lane closer. In the downside of that road, there is a police on there. They shut down the road. So we are using the drone to share the feed with them so that they can know when they this one start constructing, they shut down the 4 lane, and it gives a good understanding when we should shut down 4 lane or 2 lane, so that it will minimize user delay cost. Next one is the interstate CCTV pole height assessment. I did it for TDOT. Again, so before installing CCTV, we try to understand which height is suitable for CCTV. Is it 80 feet? Is it 60 feet? Is it something? Or if we choose some location, if there are any nearby sign or trees that blocks our view, so we give an assessment that if I put the CCTV in here, what is the coverage from that way, minor street, interstate?
So you refine the drone at the approximate location
Yeah,
of where the
80 feet.
CCTV would be, and then you kind of adjust it to see.
Right, yeah. So 80 feet, 60 feet, 100 feet, and then try to see what is the coverage for that. Again, you see that there's a construction happening there. So we captured the construction, and then we did some redis traffic analysis, how it is impacting. And there is a intersection in here. So how it is impacting in here, there's a long queue. So redis, we did that. So using redis, we deep dive analysis how the work zone impacted our traffic operations and what is the speed of traffic. We can validate with the drone data. Yeah, with that also we make a 3D drone mapping for that construction zone to analyze it further. This is the 3D drone map for that work zone. Using that 3D drone map, we can so this is the 3D drone map. So using that 3D drone map, you can measure any types of pavement characteristics, different taper length, what is the margin taper or shifting taper or different properties of the work zone. And then using the 3D model, we also did some experimental volume input in the bistro BC model. And using that different scenario, we create different scenario for traffic on that work zone, like 30% drag, 15% drag, 5% drag, and we analyze it in different time of the day, try to identify because of the work zone, what is the worst or good traffic signal management on there. And then also this one is I didn't do it, but it's mainly DDI. You can monitor the DDI signal, traffic signal, traffic queue length on the DDI. So it's mainly showing some if there is signal in here and in here, how can you operate? How can you manage different queue length? And, so having a drone footage, it will give you better understanding to operate DDI. I think Salem district has one DDI.
Yeah, we have several across the state.
Several. And then 3D drone mapping. Again, using that drone, we can also go for the accident reconstruction. The drone 3D mapping. So using the 3D map, you can investigate the accident and you have the ability to measure different feature of the crash. Like in here, nearby drainage facility, why there is a so this is the 3D mapping there. So they try to understand what is happening, and they also share this footage with their insurance provider.
Something like that actually may be very valuable because I assume the rest of the state still does fatal reviews. I know when I've been in Salem, Brett Randolph's group would go out and they would review every fatal that would happen in the district. So to be able to get a shot from an aerial view of something like that would probably be very valuable.
They can use the drone and they
Florida actually uses, when I was there, they're using the drone to for any lane blockage and the fatal accident crash too. So they fly the drone and see like how long is the queue, and then the actual scene, what is happening there too. So and they'll share the feed with like the TMC. So like we are in the TMC and pilot was in the field.
As of right now, we're letting the VSP handle those in the fill case, and then we get the data back for them after the fact. That's not something that we're again actively pursuing, right? As a case, we might go back and look at it after they move the car, like what our consultants are providing. But that investigation piece right now is being handled. That collection piece for the accident reconstruction is being handled by the VSP for us.
Yeah, so for using the drone, we can monitor the hazmat overspill on there and how the queue is happening near to the interstate, and based on that, we can do the signaling timing to clear the queue. And then again, using drone, we can do the condition diagram for crash assessment. This gives us the realistic assessment of roadway traffic and environment. And then if they are in a railroad, and then work zone, and then if you have pedestrian facility, using the drone, you can study the full corridor and understand different complex scenario. Like this is a really complex scenario. if rail coming in there and construction in there, this is the worst case. So using that, you can also fly the drone, see how can you impact it. Yeah. And then also Warzone, we can also make 3D drone mapping and analyze different taper length, different like this one, where we need to place it and how it is impacting our traffic operations. And again, Warzone, we can estimate downlifting taper, shifting taper, like 45 feet. We can validate it, queue length, impact. Yeah, this is the hazmat in the intersection. So we can coordinate with TMC, emergency responder, fire, and other teams. Also, we can use the drone for queue length assessment, signal retiming, adjustment for detour planning. All right, so the other one is the data from Sky. It's really good for data analysis. And actually, VDOT, they bought one unit last year. Mr. Ray Gire and John Paul, they have their tools. So the good thing is that these tools give us the real-time data, and it has the data capability. Also, the I think generator unit in there. So the data from Sky, they have two products, one for real time, another for offline. So the real time product is called Close Insight, and the offline is called Traffic Survey. Using the traffic survey, you can put drone video or video from any camera. And their product feature is that using their product, you can do jam detection, real-time traffic data, roundabout, origin destination study, safety study, parking management study, wrong way detection, U-turn detection, stop sign violation, jaywalking detection. It's a lot. So I put a different slide that how can we use data from Sky for our signal split adjustment. I have video, but I think I don't have much time. Again, we can also use data from Sky that detector health check, like if the detector is working or not. And then also different detector health check based on that. There is some report on there. Also, using the data from Sky, they fly 6 different drones in 6 different segments of the interstate to cover 2-mile stretch of the light traffic, and they give that type of tools. We can also use data from Sky for near miss detection. So this one. So you can see that it gives some near miss. You need to put some kind of trajectory data on there, and it started tracking different near miss objects in the air. And then also you can also do the U-turn detections. So sometimes we put no U-turn on our intersection, but people do not obey. So we can also see how many violations are going there, and how can we minimize it. Their platform gives different information, like in here, you can draw a trajectory data and different gate, recorded gate, and you can put some logical statement. They can track how many people are doing the U-turn. And then stop sign violation. They have a pedestrian and bicycle counter. You can put a different types of bar in here. So whoever crossing this bar, they can count the pedestrian. So like this one, they put a bar in here, and whoever crossing, they are detecting that this is pedestrian, this is bicycle, and they give the counting things. Then also for jaywalking detection, like people they jaywalk in there, you can put different types of reason in here. You can detect the jaywalking, and then also multi-level intersection for the traffic roundabout. You can also count their speed, uh, observe the different types of vehicle like car. Um, you can monitor different gate. So
So this is all from data from the sky.
yes.
Yeah.
Also,
The bad news is we're not authorized to use that software. Um, it doesn't meet cybersecurity requirements unless you guys have it. I haven't been authorized to get it through the state VITA for VDOT to use. So unless you guys have a mechanism that I don't have access to, which would be great, we can't get it approved.
So I talked with Data from Sky, and they told me that last year, Reg, Vire, and John, they already bought their unit, and
Right,
they
but
already subscribed.
right, but they belong to the Research Council. So they fall under the community college system for Virginia Tech. They're not part of the DOT. So their cybersecurity requirements they're not subject to the same requirements that we are. We're not authorized to use anything that goes to the cloud. So they could do it. They could use that system for research studies and whatnot. Doesn't necessarily mean we're going to be able to use it for, again, bring it into VDOT and use it as part of production. And we ran into that with the software that the traffic operations study used in 2019 had the same problem. They used a software that was available that did not meet the VITA state cyber requirements. We could not bring some of their results into our operations. So they get a lot of the VT. The Virginia Tech Transportation Institute falls under the college and university system. They're allowed to do a lot of things that under research and development that we're not authorized to do in the mainstream. So that's why I was asking, do you guys at Traffic Ops have access to this?
No, and what you're talking about is any type of cloud hosted environment that's outside of VDOT's network.
Correct.
We usually have to go through a COV ramp process, and we're trying to figure out that process as we speak with a lot of other technology that we're utilizing, like signal detection, where information that gets collected from our roads and traffic control signals gets sent to a hosted system outside of our network. So it's not impossible, but we're still trying to figure that process out as we're going at this point in time. So
and design. So hopefully together we can break through that.
And a lot of this though too is with our program, yes, we're interested in the innovation and the technology that's out there, but also with this technology, with these proprietary types of systems, at what cost do we get that information where maybe we already have that information somewhere else or can collect it in a different type of way that gets us 80 or 90% there. But that's a whole nother evaluation process that we're trying to look at the same time. So
Okay.
with it being 12 o'clock, I want to be respectful of everybody's time. Keith, Nathan, Andrew, I just kind of wanted to get your guys' thoughts again. I just wanted Murad to kind of give us a taste of kind of some of his experiences and some of the things that he's touched on necessarily with drones. But I think there's a lot of potential here from the traffic signal side of the world with these. I just kind of wanted to get your thoughts and what potentially what this may look like at us trying to move forward.
Well, yeah, so, I mean, real quick.